This is some guided practice on balancing chemical equations, and what I want to talk with y'all about today is just some strategies to approach and balancing chemical equations, some general strategies. Remember that you always use whole number coefficients, and some of the little tips and tricks that I'm going to share with you are things to make it easier and faster to balance. But please remember that all balanced equations, the coefficients must be shown in their lowest whole number ratio. So let's go through some of these. And again, I'm going to share with you some tips and tricks for certain situations. Now, the first tip I'm going to show you deals with odd numbered subscripts. So, balancing equations is sort of a trial and error process. And there are certain things that you can look out for that if you see them, they're just places to start. Now, this is not a must do. This is the only way to do it. This is just some strategies that will help you get it done faster, which is, of course, what we all like to do, be more efficient. So the first strategy deals with odd numbers. Odd numbers tend to be harder to work with. So in example 1, there's a subscript 3 here. Now remember, we cannot change the formulas for any of our compounds, which means we cannot alter the symbols or the subscripts. We can only use coefficients. So one thing that I always do is if I see odd numbered subscripts in a formula, that's where I start. Also remember that your yield sign is like your equal sign, and so you want to make sure the law of conservation of mass is satisfied and that the number of atoms on the left-hand side and the number of atoms on the right-hand side are equal when you are done. So since there's a 3 here, and the odd numbers are typically kind of challenging to work with, I always start by using a 2 coefficient in front of the compound where the odd number was found. So remember, if a 2 doesn't work, you might want to try using a 4. If a 4 doesn't work, you might want to try using a 6. But usually a 2 or a 4 will do the trick. So now, we're going to kind of go back and forth until we see that every atom is balanced. So notice I have 2 times the subscript 1 gives me 2 nitrogens on this side. So you're going to look on here and you're going to see that you already have 2 nitrogens on this side because this is an understood 1 coefficient. Now let's look at our hydrogens. On this side, you multiply 2 times 3 gives you 6 hydrogens on this side. So to get 6 hydrogens here, we're going to multiply 3 times 2 is 6. So you have 2 nitrogens on this side, 2 nitrogens on this side. 2 times 3 is 6 hydrogens on this side, and 3 times 2 is 6 hydrogens on this side. So this equation is balanced, and so when you're finished, one thing I always want y'all to do is come to the right-hand side of your equation and put all the coefficients in parentheses separated by commas. So 1, 3, 2 would be how you would show your answer. All right, let's look at number 2. As I look across here, I see that there is an odd number subscript 3 where my oxygen is. That means I have 3 oxygens. So that's where I'm going to start. I'm going to go ahead and put a 2 in front of that entire compound. Now, sometimes it helps to cover up. So let's look at your potassiums. You have 2 potassiums on this side. Notice here's your yield sign. So there's your equal sign. So now I've got only 1 potassium on this side. So I need 2. So let's put a coefficient of 2 there. Now let's distribute this 2 to the chlorine. That gives me 2 times the 1 chlorine, gives me 2 chlorines on this side. And if you distribute 2 times the 1, that gives you 2 chlorines on that side. Continue on. 2 times 3 gives you 6 oxygens on this side. So how can we get 6 oxygens on this side? You're going to put a 3 times 2 is 6. 2, 2, 3 balances that equation. And that cannot be reduced. So that is how you express your answer. Let's go on to number 3. So looking at this one, I don't really see any large subscripts and I don't see any odd subscripts other than 1s. So if nothing really stands out to me, then I just kind of start with the beginning and I just move back and forth until every atom is balanced. Remember, this is your equal sign. 1 sodium on this side and 1 sodium on this side. 1 chlorine on this side, but I have 2 chlorines on this side. So I'll come back and put a 2 in front of the sodium chloride. That fixes my chlorines. Now, that gives me 2 sodiums. So to get 2 sodiums here, I'll put a 2. That gives me 2 sodiums on both sides. Now let's look at the fluorines. There's a 1 times 2 is 2 fluorines here. 2 times the 1 gives me 2 fluorines here. This is an understood 1. So your answer should be expressed as 2, 1, 2, 1. And that is in the lowest whole number ratio. You do need 4 total coefficients on that equation to say that it's balanced. Let's look at number 4. Right now, I have 2 hydrogens here and 2 hydrogens on this side. So they're balanced right now. I have 2 oxygens here, but only 1 oxygen here. So I should put a coefficient 2 in front of the water. That's going to give me 2 oxygens, and 1 times 2 is 2 oxygens. But notice it did change my hydrogens, so I have to go back and double check those. 2 times 2 is 4 hydrogens. So we're going to put a 2 here. 2 times 2 is 4 hydrogens. That balances the equation. 2, 1, 2. Balances number 4. All right, so I'm going to share with you another little trick. Now, this trick really only works whenever you see the particular situation that we have happening on number 5. Notice in this compound, I have the hydroxide ion showing up in the lead 2 hydroxide. Now, on the other side of my yield sign, notice there's a water molecule. So there's the little tip that I'm going to show you right here is only helpful when you have a compound on one side that contains a hydroxide, and on the other side, you see a water molecule. So here's what you want to do. This is a little strategy that will save you some time. Mark through the water, and let's rewrite its formula a little differently. We're not changing the number of atoms that's in the formula. We're just making this look a little different so it's easier to balance. You want to write your water as HOH. Now I want you to notice, now we see hydroxide here and we see hydroxide here. Notice I put the hydroxide in parentheses because I have 1 hydroxide on this side and 2 hydroxides on this side because of the subscript 2. All right, so let's start balancing now. I have 1 lead here and I have 1 lead here. As I said, I have 2 hydroxides on this side, so if we put a coefficient 2 in front of where the water is, that 2 distributes over to the 1. Needs to be 2 hydroxides on that side. So I have 2 hydroxides on each side. Now let's cover up the hydroxide. I have 2 hydrogens. 2 times the 1 gives me 2 hydrogens there, and there are the hydrogens in the front. So look, I have only 1 front hydrogen here. So if I put a coefficient of 2 here, that gives me 2 front hydrogens here. So I have 2 hydrogens and 2 hydrogens. Now let's look at our chlorines. 2 times 1 is 2 chlorines, and this is a 1 times 2 is 2 chlorines. So the equation is now balanced with a 1, 2, 2, 1. All right, let's look at number 6. Now on number 6, notice you have sulfate and compounds on both sides. On this side, there's a parentheses. You see there's 3 sulfates. So I'm going to put this sulfate in parentheses, and I'm going to indicate, okay, I have 1 sulfate there. So that's going to help me balance them. It saves me some time because I can balance the 1 sulfate on this side with the 3 sulfates on this side. All right, so let's start. I'm going to go ahead and start with the strategy that I mentioned earlier, and it has to do with odd numbers. So there's an odd number 3 here, so I'm going to go ahead and multiply this whole thing by 2. That gives me 4 aluminums. 2 times 2 is 4 aluminums, so come here and put a 4. 4 times 1 is 4 aluminums. So I have 4 aluminums here and 4 aluminums here. Let's look at our bromines. 4 times 3 is 12 bromines. So to get 12 bromines, I'll put a 12 here. That gives me 12 potassiums. Well, how can I get 12 potassiums here? We know that 6 times 2 is 12 potassiums. Now, let's look at our sulfates. 6 times 1 is 6, and 2 times 3 is 6. Now, Remember, I told you that my strategies are helpful, but that sometimes you might have to reduce. So this is why I always want y'all to come to the right-hand side and make sure you write your final answer over here, because this is the answer I will grade. If you look at these coefficients, you will notice they're all divisible by 2. So you do have to have the equation balanced in the lowest whole number ratio. So all of these need to be divided by 2. That's going to give you a 2, 3, 6, 1 to balance that equation. 2, 3, 6, 1 is your answer. Now, some of you may have gotten 2, 3, 6, 1 by doing it another way, and that's fine. There's many ways to balance equations, as I mentioned earlier. I'm just sharing with y'all some strategies. Now, 7, 8, and 9. These are all very challenging type of reactions to balance. We're going to learn that these are in a class of equations or reactions known as combustion reactions. Combustion reactions are easily identifiable because they start, or the reactant will have a hydrocarbon burned in the presence of oxygen, and they will always have carbon dioxide and water as the products. Now, there's a little trick to balancing combustion reactions that I shared with you in the notes. I called it the switch. And I said, remember Hollister and Company, HCO. The switch actually involves the subscripts of your hydrogens. Okay? So what you want to do when you recognize it as a combustion, and all 3 of these are combustion, we're going to go ahead and classify those right now. All 3 of those are combustions. You're going to do the switch with your hydrogens. Now, the switch involves their subscripts. So here's how it works. Whatever the subscript of the hydrogen is, here's a 4. I'm going to put that number as a coefficient in front of the other compound on the opposite side that contains the hydrogens. So that's going to be the water. So there's a 4 here. So I'm going to put a 4 in front of the water as my coefficient. Notice the hydrogen subscript for water is a 2. So I'm going to put the 2 here as a coefficient in front of the hydrocarbon. So again, look at your hydrogens. Whatever the subscript is, put that number as a coefficient on the other side in the front of the compound where the hydrogen is located. So there's a 4 here, so I put a 4 here. There's a 2 here, so I put a 2 there. Now, I'm not going to finish balancing this equation right now. I'm going to do the trick, the switch trick, with 7, 8, and 9, and then I'll come back and finish them. So again, hydrogens. There's an 8, so let's put an 8 in front of the water. There's a 2, so let's put a 2 in front of your hydrocarbon. Okay, the 8, so I'll put an 8. There's a 2, so I'll put a 2. Let's do the switch with number 9, 18. So yes, I'm going to put an 18 here. I know that sounds very large, but you're going to do the trick and it's going to work out, I promise. There's a 2, so I'll put a 2. So notice what I've done. I've not finished them, but this is the switch. This is the key. Start with your hydrogens. Whatever the subscript of the hydrogen is, put that number on the other side as a coefficient in front of the compound that contains a hydrogen. All right, now let's pick back up and balance. So now you do your carbons. That's why I said Hollister and Company. Hydrogens first, now do carbons. So I have 2 carbons on this side. So come over here and notice there's only 1 carbon there. So I'm going to put a 2. That's going to give me 2 carbons and 2 carbons. Now for some of you, it will help you if you cover up the rest of the molecule except for the element you're looking at. Notice I have 2 carbons on both sides. Now let's do our hydrogens, our oxygens last. So this is the part where you have to be very careful because the oxygens are the reason we say them to last is because they're the ones that are the hardest ones to get to balance. Now notice the oxygens show up in 2 places on this side. So you have to figure out how many total oxygens you have on the product side and then balance it with the oxygens that are here. So let's check that out. You have 2 times 2 is 4, and then you got a plus sign here. And then 4 times 1 is 4. So again, 2 times 2 was 4, plus 4 times 1 is 4. And 4 plus 4 is 8. So I have 8 oxygens on the product side. So how can I get 8 oxygens on this side? Well, put a 4. 4 times 2 is 8. Now, see if it can be reduced. All of these are divisible by 2. So you're going to say 1, 2, 1, 2. All right, let's look at number 8. We've already done the hydrogens. Now let's look at the carbons. 2 times 3 is 6 carbons. So to get 6 carbons here, I'm going to put a 6. Now let's look at our oxygens. 6 times 2 is 12. 8 times 1 is 8. You're looking at your oxygens. And 12 plus 8 is 20. So I have 20 oxygens on this side. So how can I get 20 oxygens on this side? Well, 10 times 2 is 20. Look and see if it can be reduced. They're all divisible by 2 again. So 1, 5, 3, 4. All right, let's look at number 9. We've already done our hydrogens. Let's look at our carbons. 2 times 8 is 16. So I'll put a 16 here. 16 times 1 is 16. It gives me 16 carbons on both sides. Now let's look at our oxygens. 16 times 2 is 32. 18 times 1 is 18. And 32 plus 18 is 50. I have 50 oxygens on the product side. So how can I get 50 on this side? Well, 25 times 2 is 50. This cannot be reduced, so your final answer is 2, 25, 16, and 18. All right, let's look at number 10. Notice here we have hydroxide and hydroxides. I'm going to put parentheses around it so I can balance the hydroxides with one another. And I have an odd number. So I'm going to start, I'm going to put, I have 2 odd numbers actually here. So it really doesn't matter which one you start with. I think either way it's going to work out just fine because you're going to have to reduce. But I'm going to go ahead and use the strategy just because I told you that was a strategy. And sometimes the strategy is really, really, really important. Okay. So I'm going to just put a 2 here. That's going to give me 2 irons. So put a 2 here, and that gives me 2 irons. That gives me 2 times 3 is 6 hydroxides. So put a 6 here. 6 times 1 is 6 hydroxides. 6 times 1 gives me 6 sodiums. And put a 6 here. That gives me 6 sodiums. 6 times 1 is 6 chlorines, and 2 times 3 is 6 chlorines. 2, 6, 2, 6 can be reduced. So 1, 3, 1, 3 is going to be your answer. Again, always write your final answers out to the side. I'm going to do one more with you, and then we'll finish the others next class for some guided practice. For number 11, there is a 5. That's an odd number, so I'm going to start with the 5. So let's try the strategy. If it's odd, multiply it by 2 to make it an easier number to work with. So we're going to say 2, coefficient in front of the P2O5. That gives me 2 times 2 is 4 phosphorus. So put a 4 here. And now 2 times 5 is 10 oxygens. So if I say, well, 5 times 2 is 10 oxygens. 452 cannot be reduced. So you bring that over as your final answer. 452 is correct. All right, we're going to stop this for now. And next class, we'll use the remaining ones for the rest of our guided practice.